Hi, let's look at today's lesson. We will be looking at the exponential function. The exponential function. The form of the exponential function is y equals to ab exponent x plus q. Right, where q is the asymptote. Right, q is the asymptote. So we have only one asymptote in this case, and it's the horizontal asymptote. Right, so the shape of the graph will be, now if our asymptote it's maybe the x-axis, then our graph will either be this way, that is the shape, or it will be this way. Right, it will be either the first one or the second one if the value of a is positive. If a is positive, then the graph will be drawn above the asymptote. But if a is negative, so the graph will be drawn below the asymptote. So we will either have this type of a graph or we will have this type of a graph. So so that is where a is less than 0. So the graph will be drawn below the asymptote. Now we have the shape, we have the equation. So now let's get to the sketching of the graph. So now let's say we have the graph of y equals to 2 exponent x minus 4. So we are going to sketch this graph. Y equals to 2 exponent x minus 4. So we will start with the asymptote. So the asymptote, so the equation of the asymptote will say y equals to negative 4. So we have our horizontal asymptote. And then we get the intercepts. So let's start with the y-intercept. So y-intercept, we know that the x value is 0. So it means our y will be 2 exponent 0 minus 4, which will give us 2 exponent 0 is 1 minus 4 is a negative 3. So it means our graph will cut the y-axis at negative 3. So let's look at the x-intercept. The x-intercept, we know that the y value is 0. So we will have 0 equals to 2 exponent x minus 4. Taking the 4 that side, we will have 2 exponent x equals to 4, which we can write it as 2 exponent 2. Right, so in other words, the bases are the same, so x equals to 2. Right, so now we have the x-intercept and the y-intercept. Right, so we need to understand that if, when we draw the graph, if the value of b, remember we said we have our graph y equals to a b exponent x minus or plus q. Right, if this b here it's more than 1, if b is greater than 1, then our graph, it's going to be an increasing function like this. Right, but if b is less than 1, so let's say it's between 0 and 1. So if b is between 0 and 1, then our graph is going to be a decreasing function. So it's going to be a decreasing function like that. So we need to understand this. So now in this case, if we look at our function, the b value, it's more than 1. Therefore, we are going to have this type of a graph, right? So, but then we don't have to cram that. What we can do is, if we don't we have another point, we can get another point. So, but here we already have 2 points. We have the point where x is 2 and y is 0, and we have another point where x is 0 and y is -3. Here we are safe, so there's no need for another point. But if in case we only have 1 point, we want to determine the direction of the graph, we can always get the second point. We will look into the next example, but now let's sketch this function. We have so this is the x-axis, this is the y-axis. We have a 0 there, and then let's say this is our asymptote at -4. So we have our asymptote at -4, the y-intercept at -3, and then we have the x-intercept. We said that the graph will cut the x-intercept at 2, so we will have 2, and then we sketch our graph. So it's an increasing function. So this is an increasing function. This is our asymptote, so it cuts the x-axis at 2 there. So this is how we sketch the graph, right? So suppose let's take the graph of y equals to another function of y equals to, let's say we have 3 to the power -x. Now we can clearly see that the asymptote is at 0, so y is 0. It's 0, so the asymptote is represented by what is added here. So if it's just like that, is plus 0. So we have the asymptote at 0. Now the y-intercept, we know that the x value is 0, so we'll have y equals to 3 to the power -0, so which is 1. Any number to the power 0 is 1, so it means the graph will cut the y-axis at 1. So if we try to calculate the x-intercept, we know that the y value is 0, so we will have 0 equals to 3 to the power -x. Now there's no way we can be able to solve for x here. There's no number that we can substitute there and we get a 0, so it means this one is undefined. Now if it's undefined, it means that there is no x-intercept. So we can write it, there is no x-intercept. So our graph has no x-intercept. Of course, it's because the asymptote is at 0, and we are actually drawing the graph above the asymptote, and the asymptote is at y equals to 0. I mean, so we look at the asymptote, it's at y is 0, and we are drawing it above, so that is why there's no x-intercept. So let's try to draw this graph and see how it looks like. But like I said before, here we only have the 1 point, which is the y-intercept, so it is important to get another point. So we take any x value, we can choose any x value as long as it's okay for us. In this case, I'll choose a -1. So let's see what happens where x is -1. So according to the equation, y will be, we said, is 3 to the power -x. So in other words, y will be x, we're choosing it to be -1. So a negative and a negative is positive, so y will be 3 to the power 1, which is just 3. So in other words, the other point that we have is -1 and 3. So in this case, because we have the second point, it will help us to give shape to this graph, to get direction, so that we don't have to cram that when we have a value of b to be this, then the graph will be like that. So we can just get the second point. Right, so now we said that our graph intersects, okay, the y-intercept, we said it's actually cutting at 1. Y-intercept is at 1 and the asymptote is at 0. So in other words, our graph will cut here at 1, right? And this line, the x line there, the x-axis, it's the line y equals to 0. It's our asymptote, and therefore we have our next point. It's where x is -1, and we just seen that y value is 3. So this is the other point. Now this, it's now showing us the direction, so it means we will have our graph like this. So the graph will be like that. So this is how we sketch the graph. But then we can see that the a value, as we look at this graph, we realize that the value of b, it's actually between 0 and 1. So how do we see that? So we have 3 to the power -x. We can rewrite this as 3 to the power -1 times x, which actually gives us 1/3 to the power x. So you can see 1/3 is between 0 and 1. So 1/3 is between 0 and 1. Hence we have a decreasing function like that. But as I said, you don't have to cram this. All we have to know is just to get another point. So that point will help us in determining the direction of the graph and ultimately drawing the graph. Right, so we now know how to sketch the graph. So let's learn how to calculate the equation of the graph. Right, so we are now checking the equation, how to calculate the equation. Now let's say we have that function that we have drawn. We said this is -4, this is -3, and this is 2, and we want to calculate the equation of this function here. Right, we will just say the equation is y equals to, we can use a exponent x plus q. Right, so we can use this equation. Now we can substitute the asymptote. So the asymptote is -4, so we have y equals to a exponent x minus 4. So we have the 4 at q, and now we want to know this a, so we can substitute the point. So if it is like this, please don't substitute the point at the y-intercept, because that one will help us to get the value before a. So it won't help us to get a, it will actually eliminate a. So we'll see what I'm talking about. So let's use this one at 2 and 0. So the y value is 0, and the x value is 2, and this is minus 4. Now we take the 4 that side, so we will have a squared equals to 4. When it goes to the other side, it's positive, so the square root of a is 2. So in other words, our function will be y equals to a is 2 to exponent x, then minus 4. Right, coming back to the fact that please, when you substitute, when it's already like this in this form, don't substitute the -3. We actually go back to the general form that we talked about. We said it's a b exponent x plus q. All right, so now if we substitute the -4 there, we'll have a b exponent x minus 4. Now we want to get this a here, so we substitute this y-intercept there. So we have the -3 equals to we substitute x, so we have a b to the power 0. So the x value here at 3, at negative y is -3 is a 0. Then we have a minus 4, and now we can take the 4 to the other side, so it's going to be plus, so it's going to be minus 3 plus 4, which is 1. So we have a into b to the power 0 is 1, so it's giving us a to be 1. So you see, so now it means the value of a is positive 1, so hence we have our function as y equals to b to the power x, because a is 1, then we have minus 4. And now we substitute the 2, we will have y equals to, so let's put 0 here instead. Right, so we'll have a 0 equals to the b, then we have a 2 there, and then minus 4 as we did that side. So we have b squared is 4, and we have b to be 2, and hence we are able to get our equation as y equals to 2 exponent x minus 4. So we need to be careful where when we substitute the -3. So it means we use, the 0 and -3, we use the 0 and -3 to get the coefficient of the base of this exponent. So hence we got 1 there. So, and then that's how we calculate the equation. So let's look at the other graph that we had. So we had this is our graph. So remember, we had the point -1 and 3 here, and here we had 1. So, and the asymptote is at the x-axis. So if it's at the x-axis, so it's simply y equals to a exponent x. Right, so it's plus 0, so we can just write it as y equals to a exponent x. Now remember, we cannot substitute this one because that one is just helping us to get the value before this one. Or if we want to, we may write it as y equals to a b exponent x, and then if we substitute the 1 there, we will have y value is 1, and then we have a b x value is 0. So you can see b to the power 0 gives us 1, so we have a to be 1. Right, and then now we write our equation y equals to 1 times b to the power x. So now we need to substitute the other point. So the other point is given to be a -1 and 3, -1 and 3. So we substitute it, so the y value is a 3, the x value is -1. So if we solve, we can divide both sides by -1, so the b it's actually 3 to the power -1, which is the same as 1/3. Or somebody may change it here and say, okay, b to the power negative 1 is 1 over b, which is 3, and then multiply by b both sides. So we will have 1 equals to 3b, and divide by 3, so b is 1 over 3. So in other words, the equation here will be y equals to 1 over 3 to the power of x. So the 1 over 3, we can change it to be 3 to the power negative 1 exponent x, so it's 3 to the power negative x if we multiply the 1 by x. So that is how we calculate our equation. Alright, so that's how we calculate the equation. So the next thing that I want us to do is to look at the domain and the range. The domain and range. Now, with the domain, for an exponential function, if we just take any one there, the exponential function, the domain, any value of x, if you check, there's nowhere any x value can touch the graph. So we will take all values of x, they form part of the domain. So it means we'll just say x is an element of real numbers. So hence they never actually ask for the domain of an exponential function. Right, what they will rather ask is the range. Now the range, so we want the y values that are defined on the graph. Right, so if this is our q, that is the asymptote, so we will say the range of this graph is y is greater than q. Right, so as long as the value of a is less than rather it's bigger than 0. So in other words, as long as a is more than 0, in other words, the graph is drawn above the asymptote, above this line, then it means the range will be y is greater than q, whatever q may be. So but if the graph is drawn below the q, this is our q, so and the graph is drawn below, so it means the range will be y is less than q. So in our two graphs that we have seen, let's look at the domain and the range of the graphs that we have drawn. Right, let's start with this one. Can you see this one? The range of this one, we will simply say y is greater because it's drawn above the q line, and this in this case the q is a 0, so this asymptote is 0. Right, so that is the range. Now let's look at that other one, this function here. Now the range of this function is also drawn above the asymptote, so we'll say the range is y is more or greater than a -4. So that is the range of this graph here. So it's very easy to get the range. Just check whether the graph is drawn above or below, or check the value of a. If a is positive, then it's above. If a is negative, then it's below. So it means if it's positive, then it's the range will be greater. If it's negative, the range will be less. So that is the domain and the range. As we have said, the domain, it's taking all, x is taking all real numbers. So x is taking all real numbers. So but what they can ask is the range. So please remember, the q, because it's the asymptote, is not included. So do not make a mistake of including the q. Don't put an equal sign, don't say greater or equals to. So you don't include this q here in this case. Unlike the parabola, if it's, remember, if it's a parabola, it's like this, and there's a q here, the y value there. They said, what is the range? You will say y is greater or equals to q. So in this case, it's included. But with our exponential, it's not included because it's the asymptote. The q here is the asymptote, but here the q is part of this graph. So hence we put greater or equals to. Thank you very much. So now we continue. We go to the we are now looking at the transformation. So let's look at the transformation. So let's go back to the transformation. All right, so the transformation, let's go to the before reflection. We let's see how we can shift the graph, the translation. So suppose we have our function y equals to 2 exponent x minus 4, and we want to shift this graph. Let's say we want to shift it, shift the graph, let's say 1 unit to the left and 2 units up. Right, let's see what will the new graph be. So we will have y equals to 2 to the power x and then minus 4. So for up and down is this one, so we'll just add a 2. Left and right is on x, so they are saying we are going to the left, so to the left we add. Remember, to the left we add, to the right we subtract if it's on the equation. So it means our new function will be 2 exponent x plus 1 minus 2. So this will be the new function after we have performed this transformation. Right, so let's take maybe another example. Let's say we have y equals to 3 to the power x. Right, so let's do reflections on this one. So we want to do reflection. Right, so the first one along the y-axis. So we want to reflect along the y-axis. Remember, reflection along the y-axis exchanges the sign. So in other words, if we want to reflect this function here along the y-axis, so the new function will be y equals to 3 exponent negative x. So the x changes the sign. Right, now the same function, let's look at it along the x-axis. So we are looking at reflection along the x-axis. Remember, the function is y equals to 3 exponent x. Now in this case, along the x-axis, it's y that will change the sign. So we'll have negative y equals to 3 to the power x, and then this will tend to, we multiply both sides by negative 1, so y will be negative 3 to the power x. Right, so that will be the reflection along the x-axis. So y changes the sign, but eventually it will give us this. Right, and then the last one that I want us to talk about, it will be a reflection along the line y equals to x. So a reflection along the line y equals to x. Remember, this we said is the same as calculating the inverse. A reflection along the line y equals to x it's actually the same as calculating the inverse. So if we look at our function y equals to 3 exponent x, step number 1, we will exchange x and y. So we will have x equals to 3 exponent y. And then step number 2, we will solve for y. We will make y the subject of the formula. All right, so now in this case we are introduced to a new thing. We want to get rid of this y here. We want to make it the subject of the formula, right? So now this exponent here, it's actually a logarithm, so we will simply say y is a log. Now we will talk more about this in the next module, so but for the purpose of this one, it will be a log. The y is a log. Now this 3 is a base and this x is a number. So the y is a log, the 3 is a base, and the x is a number. So we need to understand that the exponent is a log. This exponent is a log. The exponent is actually a log. We need to remember that the exponent is a log, right? And this is the number, x is the number, and this 3 is a base. All right, so where do we put the base and where do we put the number on the log? So let's start with the number. The number is x, the base is 3. So this is how we get the answer, but for more details we'll be talking about the exponents and the logs in the next module. So but this is how we calculate the reflection along the line y equals to x, or simply the inverse. So this is the inverse of the graph y equals to 3 to the power of x. Thank you very much. Please don't forget to like, share, and subscribe. Thank you.